डाउटनेट पर होगा आपके सारे फिजिक्स के इंस्टीट्यूट मैथ्स और उसका सफाया। बस अपने फोन से क्वेश्चन की फोटो खींचो, क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड कीजिए डाउटनेट ऐप अभी या फिर व्हाट्सएप कीजिए अपने डाउट्स 8 400 400 400 पर।
इस क्वेश्चन में दिया हुआ है कि एक क्लासरूम है जिसकी डायमेंशन दी हुई है दैट इज़ 5 × 10 × 3 मीटर क्यूब और जो कि 20 डिग्री सेल्सियस के टेम्परेचर पे इनिशियली है एंड द प्रेशर इज़ केप्ट कांस्टेंट एट 1 atm। और उस क्लासरूम में 20 जने लोग हैं एंड ईच लूजिंग एनर्जी एट द एवरेज ऑफ 150 वॉट दैट इज़ 150 जूल्स पर सेकेंड। So ये assume किया गया है कि the walls, ceilings, floor and the furniture are perfectly insulated and they don't absorb any energy and तो हमें इस डेटा से ये कैलकुलेट करना है कि how much time will it be needed for raising the temperature of air in the room to body temperature जो कि दी हुई है 37 degrees Celsius and for air the CP value दी हुई है that is 7/2R and loss of air to outside as the temperature rises may be neglected. So we need to find first we need to find the net energy that is required in order to raise the temperature from 20 degrees Celsius to 37 degrees Celsius. Therefore we need to find the change in enthalpy, net energy, that is delta H is equals to, and since it is at constant temperature, it is at constant pressure, therefore Q will be equal to delta H is equals to N Cp dt. So first we need to calculate the number of moles that is unknown to us. Cp is given and the change in temperature we know. So for moles, N is equals to PV by RT in the initial condition. So pressure is 1 atm. So the pressure is 1 atm. Volume is 5 × 10 × 3, that is 150 meter cube, and if we represent that into liter we need to multiply it by 10⁻³ R is 0.0821 and temperature is 20 degrees Celsius, that is 273 plus 20 Kelvin, that is 293 Kelvin. On solving this you will get the number of moles as 6.236 into 10⁻³. This is the number of moles that is present in the room initially. So अगर हम ये number of moles को इस equation 1 में substitute कर देते हैं, so Q is equals to delta H is equals to 6.236 into 10⁻³. Cp is given, that is 7/2R, and change in temperature, that is this 37 minus 20, that is 17 degrees Celsius, represented in Kelvin. That is the difference will be 17 only. So if you calculate this, you will get delta H as 3.085 into 10⁻³ joules. So this is the amount of heat that is needed. So amount of heat needed to raise the temperature from 20 degrees Celsius to 37 degrees Celsius is 3.085 into 10⁻⁶. Actually it's 10⁻⁶. 10⁻⁶ joule. This is the amount of heat that is required. Now we need to find how much time is needed. So if you clearly see, there are 20 people in the room and each is losing energy at the rate of 150 watt, that is 150 joule per second. So heat released by 20 people So heat released by 20 people per second is 150 into 20 joule per second, that is 3000 joule per 3000 joule per second. So total time needed, now we know that 300 joule of energy is released by the group of 20 people per second. So now time can be easily calculated. Time needed is the total heat that is required, that is 3.085 into 10 raised 6 joule by the rate at which heat is liberated, that is 3000 joule per second. So if you calculate this, you will get around 1028.35 seconds. So the total time needed in order to raise the temperature of a room from initial 20 degrees Celsius to 37 degrees Celsius is 1028.35 seconds. So this is the final solution of this question.